何？お前はもう死んでいる。
Safety procedures in laboratory. Make sure to follow all the instructions given. Wear a safety goggle and a glove. Do not eat or drink in lab. If accident occurred, quickly report it to the person in charge. Make sure to leave the lab clean after doing the experiment. Make sure to turn off the light, tap water, and fan after you are done using the lab. The objective of this test tube is to determine the compressive strength of concrete cube for 7 and 28 days curing.
Next, theory. Concrete cubes are made on site to check that the strength of the concrete is above the minimum strength, which has been specified. Compressive strength is the ability of material or structure to carry the loads on its surface without any crack or deflection. Test for compressive strength is carried out either on cube or cylinder. This test measures the uninitial compressive strength of concrete cubes, which are made, cured, and tested to very specific requirements. It does not measure or predict in any unique way the strength of the concrete in the structure. The test is simply a quality control test which measures the consistency of the concrete in terms of one particular property, compressive strength, using an arbitrary test method. Testing the same concrete under different conditions, for example, specimen size, specimen shape, curing temperature, loading rate, and others, will give different results. Casting, curing, and testing cubes should be carried out in the correct manner. Even small deviations from the standard producer will usually lead to compressive strength results which are lower than the true strength of the concrete. For example, for each 1% air entrapped, there will be a 4 to 5% loss of strength. Next, materials for this slab is cement, sand, fine aggregate, granite stone, crushed aggregate, tap water, and grease oil. And next, the apparatus or compression testing machine, sampling tray for concrete mixing, shovel, scoop or trowel, steel float, compacting bar, standard cube mold, size 150 mm by 150 mm, weighing balance, brush for applying grease to mold, and spanner for tightening cube mold.
Procedure. First, proportion of ready mixed concrete was prepared and the material required was calculated. The material of each cube should be mixed separately according to their ratio, using concrete mixture ratio of 1:4 and 1:6. All inner surface of standard mold must be wiped by grease oil using brush. The concrete mixture was poured in with 3 layers of approximately 50 mm deep each. Every layer must be compacted by compacting bar not less than 25 strokes per layer of concrete. Compaction should be done in a uniform manner over the cross-section of the mold. The top of the mold level was smoothed with steel float. The procedure was repeated for another 2 molds. The specimen was demolded after storing it in a vibration-free place and in conditions that prevent loss of moisture for 24 hours. Immediately, the specimen was submerged in water at 27+2 Celsius in a water tank. Cube will be tested on day 7 and day 28. Before immersing, every cube must be weighed and stacked as M1. Once again, on the test day, the cube will be weighed instead as M2. Ensure that all testing machine bearing surfaces are wiped clean and that any loose grit or other extraneous material is removed from the surface of the cube which will be in contact with the platens. The cube on the lower platen was carefully centered and ensured that the load will be applied to two opposite cast faces of the cube. The cube was placed on the bottom plate of compression machine. Make sure the bottom and upper plate touch the cube by releasing the load valve. Without shock, the load was applied and increased continuously at a nominal weight within the range 0.22 Newton to 0.4 Newton until no greater load can be sustained. Due to the constant application of load, the specimen started cracking at a point and final breakdown of the specimen must be noted. The maximum load applied to the cube was recorded. The procedure for another two cubes were repeated on day 28. The compressive strength of specimen can be calculated by dividing maximum load carried by the specimen by a cross-sectional area of the specimen cube. Express the result to the nearest 0.5 Newton. So this is the result.
The characteristic concrete strain is the strain of concrete specimens cast, tested and cured for 28 days according to the given operating specification. On the 28th, the compressive strength of concrete almost reached its maximum value. Therefore, we tested the strength of concrete and relied on the result we obtained to evaluate its compressive strength. The density of concrete has an influence on the compressive strain of concrete. For example, high-density concrete has higher compressive strain due to its compactness. This is because, due to the smaller number of voids, the amount of required to crack concrete is larger, which means that it can withstand greater loads or pressures compared to the less dense concrete. What we can conclude from this test is the average compressive strain of the cube on the 7th day was 11.88 MPa. At the same time, the average compressive strain of the cube on the 28th day was 19.39 MPa. Based on this result, I conclude that the compressive strain of the hub increased over time until it reached its maximum compressive strength.